In electric circuit analysis or network theory or circuit theory, the basic electrical engineering, Kirchhoff voltage law solved problem 2. So find the current flowing through 8 ohm resistor and power supplied by the battery using KVL. So here there are 3 loops. Solution: apply KVL to loop 1. So the loop 1 is where the current I1 flows. So this is loop 1. So in this loop we are going to apply KVL. So first KVL is summation of EMF plus summation of voltage drop is equal to 0. So the summation of EMF, the EMF is the voltage source available here is 20 volt. So whether we need to put plus 20 or minus 20, so that is decided by the direction. So the direction of EMF will be in this path. So by seeing this, we can understand that the EMF is leaving the positive terminal of the voltage source. So that means it must be given positive sign for the EMF. So plus 20 and plus summation of voltage drop. So here the drop across 8 ohm resistor and 3 ohm resistor must be considered. At 8 ohm, the direction of current flowing through the impedance and the direction traversing round the loop both are same. So that means we need to substitute the drop as negative. So minus 8 into the current flowing through this 8 ohm resistor is I1 is flowing here and I2 is opposing. So we are writing the KVL equation for loop 1. So this I1 is a main current and I2 is the opposing current. We need to write I1 minus I2. And here also the direction of current flowing through the 3 ohm resistor and the direction of traversing round the loop are same. So we need to put minus sign and 3 into I1 is a main current, opposing current here is I3. So I1 minus I3. This will be equal to 0. So this is how you need to write the KVL equation for loop 1. So simplifying this equation, multiplying inside the bracket and taking I1, I2 and I3 separately, and you will be getting 11 I1 minus 8 I2 minus 3 I3 is equal to 20, and this is your equation 1. And apply KVL to loop 2. So this is loop 2. So in this loop 2, we are going to apply KVL. So first, summation of EMF, one voltage source is there, the direction is towards right hand side. That means the EMF leaves the voltage source at positive terminal. So it must be given positive sign. So plus 5. And there are 3 resistances, 3 ohm, 8 ohm and 4 ohm, across which will be having a drop. So the direction of current flowing through this 3 ohm resistor and the direction of traversing round the loop both are same. So we need to put minus 3 into second loop equation. So I2 is a main current, I2 minus the opposing current is I3. And in 8 ohm, again the direction, both the directions are same. So minus 8 into I2 is main current, opposing current is I1. And here minus 4 into only one current flowing through this, it is I2. This will be equal to 0. Multiplying inside the bracket and simplifying, you will be getting minus 8 I1 plus 15 I2 minus 3 I3 is equal to 5. This is your second equation, KVL at loop 2. Now apply KVL to loop 3. So in loop 3, there is no voltage source. So no need to worry about this 2 points and this EMF. We are going to write only voltage drop. So voltage drop across 3 ohm resistor, 7 ohm resistor and this 3 ohm resistor. So first we will write the voltage drop across this 3 ohm resistor. So 3 ohm resistor, the direction, don't worry about the direction. So we can put plus 3 into the current flowing through this 3 ohm resistor. So we are writing the third equation. So the main current is I3 and opposing current is I2. So I3 minus I2 plus 7 in this 7 ohm resistor, only I3 current is flowing. So plus 7 I3, and in this 3 ohm resistor, I3 current is flowing, opposing current will be I1. So 3 into I3 minus I1 equal to 0. Multiplying inside the bracket and simplifying, taking I1, I2 and I3 separately. So we'll be getting 3I1 plus 3I2 minus 13I3 is equal to 0, and this is your third equation. So these are the 3 equations we derived by applying KVL to all the 3 loops. We can solve this 3 equation using a equation mode in a calculator, and we can obtain this I1, I2 and I3 directly. So I1 is equal to 4.58 amps I2 is equal to 3.13 amps and I3 is equal to 1.78 amps. And in the problem they asked to find the current flowing through 8 ohm resistor. So the current flowing through 8 ohm resistor is, so actually this I1 current is flowing this path and this I2 current is opposing. That means I1 minus I2 will be available at this 8 ohm resistor. So I8 ohm is equal to I1 minus I2. Substituting directly, you will be getting 1.45 amps. And second one, power supplied by the battery. So here there is no battery symbol. The first loop voltage source will be taken as battery. Usually the first loop is taken as a reference. So this we can take it as a battery. The power supplied by this battery we are going to consider. So the power will be equal to voltage into current. The voltage value is available 20 and the current across this battery will be equal to I1. So 20 into I1, that gives you 91.6 watt. So power will be equal to 91.6 watt. So this is how we need to solve this problem using KVL.